and priorities, right, based on the product phase. Let me take a minute here to just highlight this point based on the product phase. So this is a typical product, right, SMB kind of a product. It goes through a typical product life cycle, right. So first, it is a concept. Any product is a concept. Product is taken to a market, right, by the business development team. And when the product goes to a market, it basically identifies its position in the market, right. It's not always the time. For example, one of the EMR products, right, in the healthcare, EMR, electronic medical record product, they got into the market and then they struggled hard. Eventually, one of the intelligent business development guy took this product to a medical institute, and they figured out this product. They had a requirement, medical institute, that particular medical institute had a requirement where they wanted a product to be used, some kind of a product to be used for training purpose. So eventually they got into this segment and they became one of the leaders in that segment, right? So product has established its position in the market. Then it goes to some early implementations, right? Gets a lot of feedbacks, and then a lot of features which you feel, because of this, what happened is learning management system became essential part of this product components, right? So what happens is, because of this, a lot of features that you feel are not important, right, all of a sudden they become important. Your product core focus is shifted to that, right? Till then, scaffolding of your product is not very strong, right? Still, the development of the core product is not complete. So basically, your test areas and priorities are different in this phase. When your product establishes a segment, then it wants to be a leader in that segment, right? Then basically, then there are different challenges: scaling, dealing with the complexity, and so on and so forth, right? So till then, the priorities are different. After your product is established, your priorities are different. Upgrades, data maintenance, data migrations, and so on and so forth. And then one of the questions that you ask is, what technologies would I like to use? Now, again, going back to the test automation framework, we typically, it takes 4 to 6 weeks to come up with a, yes. Why is it a different area? No. Code coverage is basically when I test my product, whether by means of automation or manually, I need to know how much my test cases, how much of % of my code they are covering. That is a code coverage. What's your definition of code coverage? So you mean that the code is developed, right, and there is dead code. How do you identify that? Exactly. You write test cases, whether it's unit or integrated or system level, right? You write test cases, you do instrumentation of the code, you run the test cases, it gives you a report as to which code was not touched at all, right? Then you go to the code and figure out whether this code is really useful code or not. If it's useful, that means you are not covered that code with the test cases, right? So you write more test cases for that. If it's not useful, it's a dead code, right? You just need to remove that code. Yeah. Correct. So that whether it's a dead code or not, see, there are only two outcomes to it, right? Either you do not have sufficient test coverage, right, or your code is a dead code, right? It is supposed to be removed. Now, let's say theoretically, if you have 100% test automation coverage at even functional level, it should execute all of your code. Correct. So that's what the report will tell. Actually, when you do code profiling, the results tell you that this. Yeah, I think it's a good idea. We can take it offline. Definitely, it was a very valid point actually, and very important one. And we should talk about it, right? It takes around 4 to 6 weeks to design my basic framework. Again, it can evolve over a period, and then it can cover a series of tests, right? Why only UI tests? It can cover unit tests. It can cover regression tests. It can cover within regression tests. It can cover a bunch of tests such as UI tests, functional tests, API tests, device compatibility tests, which have become an important aspect of release nowadays. Because support to less number of devices or browsers or platforms means access to less number of customers as proportionate as that. Volume tests, right? Typically, when the product goes to early implementation phase, one important need is that what is behavior of my product when it's subject to the volume, decent size of data. Performance and load test. I can club pretty much everything together under one harness, one framework. So I can again basically go back to my framework components and figure out what's going to be my test harness or driver. I can use industry standards tools such as JUnit, Unit, Test Engine. Many times people typically integrate that with custom integration or continuous integration tools. I can have my or instead of using any industry standard tools, I can go with a custom harness. I can build my own scripts, driven from Excel or anything that I like. Good dashboard, I can figure out what should be my dashboard, what are important parts, what is my top management looking for, what is my intermediate management looking for, and actual test automation guys looking for. Logging mechanism, reporting engine, notification engine, and other features I can pretty much add. So then I can also figure out about test automation tools and libraries, right? So this is where the whole solution approach, this is where test automation tool comes in, right? This is just one component of entire framework. This is just one node component. Typically at UI automation layer, we get confused, right, with test automation tool playing test automation solution role. It's very simple. At UI layer, it just basically if a new employee comes in the organization and then this employee, HR takes this employee or manager takes this employee to introduce to other team members. Typically, you need to recognize, associate people with their names, right? How do you do that, right? You map certain properties, right? Your dressing style, physique, and other spec, no spec, so on and so forth. You typically associate that and keep it in your memory, right? Eventually, when you meet these people at different places, you typically take out those attributes and try to figure out what is the name of that person, and then you interact with that person. This is how test automation tool works. That's all. That's the only value added by test automation tool, nothing else. You should not get confused that because it's being intelligent by virtue of doing this thing, it can be your entire product validation kit. So outcome is test automation. If we follow solution approach, test automation is in line with the test strategy and hence product quality goals and business goals. Framework is self-sufficient because we've taken decisions, we have evolved it. It can evolve with the product and testing requirements, the focus at the different phases. If it's different, I can focus on different things. Does not need upfront capex and vendor dependency, right? So we can figure out when we want commercial tools to be used and to what extent. Can add right commercial as well as open source tools at right point in time. And it is the most important or a very important aspect is a single consistent interface with the familiar technology. So according to team likings, right? So if I like Java, I like .NET, I like Python, I like Perl. Whichever thing I feel that's my organizational strength or my QA team's strength, we can use that interface and use that. So it can be integrated. It becomes very easy to integrate with any CI tools. Nowadays, DevOps, process automation is also being talked about. So it's very important that I should be very comfortable with the technology, right? So that's where. So we have a few minutes. So we'll quickly go through this case study where we use this solution-based approach. This product is an online marketplace for services. So where local service providers they publish their services on the net. on this application, and then consumers can book and avail the services like hairdresser, doctor appointments, and so on and so forth. So this is a typical architecture. So by some reason they chose .NET as a technology stack. Database however was MS SQL. Then it's like it supported mix and match. So we had Android and iOS support, and pretty much all leading browsers they supported. So it was in the conceptualization phase. So it's just looking for early customers, getting ready for early implementation. So we had API testing, pretty much at a unit level was the focus. Then user scenario based testing, user interface testing, usability testing, and volume testing. They were the focuses. Right? They were main requirements of test strategy. Out of focus, elaborate PSR, performance, security, and reliability testing, and elaborate component testing. It's not like some P2 activities there. So we use this new concept or methodology, behavior-driven development, because user scenario-based testing was one of the requirements. This is the metrics that environment metrics that was supposed to be supported. So we conducted test automation proof of concept where we took these P1 requirements from the test strategy, and then we set up. We typically, it took us 2 sprints, 2 weeks to complete the POCs, and these were the goals that we tried to address. We had to automate sanity tests, so user scenarios, automate mobile plus web scenarios, API tests, volume tests, support BDD approach, because this was like being used for testing purpose, and .NET for test hardness, because that was the technology protocol we were using. This is the framework that we had a batch file. I'll talk more about that. We supported 2 engines, these 2 tools mainly, or other engines to support the tools. Calabash to the mobile Specflow. This helps you with the BDD. And then we had this BDD feature files. Anyone has worked with BDD in the automation context? Okay, nobody. So, anybody has worked with BDD in the manual testing context? This is the right conference I'm in, right? It's a behavior-driven development. So basically, what happens? I'll take a minute to talk about BDD. What happens is earlier days there was TDD, right? What is test-driven development? Okay, so you write tests first. Okay, I write a function. Let's say very simple case of a login authentication, right? I have a first case where I write a test. I want login to work with verified login should work with valid user ID password, right? Or whatever authentication tokens we pass along. Then my developer and I'm going to fail it because there is no implementation for that. Developer job is to make sure that this test passes. That's all. The only thing he or she has to do is to make sure that test passes. Then I write 2 more tests. Right? It should not work with very other specific combinations of user IDs and password. Right? So it will fail there because that code is not implemented. Developer has to just make sure that those functions are passed. So that way, test is driving development to complete the functionality. Right? Developer's job is to just convert that. It becomes a requirement. It's easy for a developer because it can relate to the functions in an easier way than subjective piece of information in requirement specification or design or whatnot. So that concept got a step forward and it got implemented in BDD, where acceptance testing, somebody yesterday talked about ATDD, right? Acceptance test visual development, right? So that's a BDD, right? So where behavior of the system typically captured by business analysts, right? So they have a specific language called Gherkin. It's a syntax where you write in a format which is starts with a particular keyword such as given I enter valid user ID and password, right? Given that I'm on the login page and I enter valid user ID password, then I should be redirected to XYZ page, right? And I should see XYZ on the page, right? So this is where basically this is the syntax or the semantics of the language. And then that is maintained in the feature files, right? So that is how we maintain that, and then each such line got a step definition classes. Now, good thing was this BDD decision came later in the story. See, this is how the solution based approach helps. So this came later in the file. So what we did, so we already had this step definition functions written. For example, we had a function called login, logout, etc., whatever, registration and etc. So we had all these functions written already irrespective of BDD. We had to write a wrapper classes on that. The other approach was to just discard the whole stuff and rewrite it according to the BDD. What we did is we just wrote some kind of a wrapper functions to cover these functions, right? So from those functions we called our native, the original functions, and that's took care of entire thing. So thousands of lines of test automation code base, we could utilize it quickly by just introducing this one layer in it. And then we had typical framework functions for the synchronization, logging, object identification, error handling, and so on and so forth. Reporting, we supported both the reports. For the mobile, we support Calabash reports and HTML reports for the web application. So, and our also environment support for the object repository. Someone just talked about the object repository. So we maintained different components there. So these are the highlights of the framework. BDD for the test documentation, driven by the team. .NET technology for the test harness. Cucumber for spec flow. Cucumber for again, driving Calabash. And spec flow for our WebDriver. For the BDD implementation, we had Windows batch file plus Jenkins as a test driver, right? So they were using Jenkins already for their continuous integration. We just added a batch script there, and it just kind of